We are ready to imagine it here at the Imagination Station, where you go big or you go home. And the chief scientist, Carl Nelson, where are you going to go?
We're going to go here. We're going to go big.
We're going to go big. He never goes home. He's always here. I'm going to put these on, too. What are we doing?
Well, this is an experiment we do every day as one of our normal demonstrations. And it's one demonstration that we get tons of questions about online all the time. How to do it, how it works, all that sort of stuff. It's called Elephant's Toothpaste.
The Elephant's Toothpaste is a crowd pleaser.
Everybody loves it. Yeah. You have to. So what it is, it's the decomposition of hydrogen peroxide. You know, the stuff you might put on a cut or a scrape, and it bubbles up.
Yeah.
So down here, I have a beaker. Two beakers. One is hydrogen peroxide, and this is more concentrated than what you have at home. It's 35%.
Okay.
And this is a catalyst, potassium iodide. What that's going to do is it's going to break down the hydrogen peroxide, and it's going to do it quickly. So what I want you to do is you're going to pick that up, you're going to just dump that in, and then kind of step back. So when it decomposes, the hydrogen peroxide turns into oxygen gas and water. And a little bit of that yellow stuff is some of the iodine from the potassium iodide, okay?
I'm pretty sure that is how Indiana Jones healed his father.
Ooh, nice, nice.
That's what it looked like.
Okay, but so that's just by itself. What makes it into Elephant's Toothpaste is if you add soap. So take that soap, and it's just Dawn dish detergent. We're going to add some. I already put some food coloring inside here. So we're going to explore a little variable here. That catalyst was what was called 2 molar potassium iodide. You have, right here in your container, 2 molar potassium iodide. I have a beaker of 4 molar, so it's twice as concentrated of a catalyst. So we're going to just mix that up a little bit.
We're doing these at the same time, or okay?
Let's prepare for what's going to happen.
But it's not a race, ladies and gentlemen.
No. So yeah, we're just going to do a 3, 2, 1, and pour. All right? 3, 2, 1, pour. And let's see what happens.
Let's just step back just a little bit here. Just want to watch it from back here.
You know what? Absolutely nothing is going to happen. You know why? Let me tell you why. We did not add any hydrogen peroxide.
Oh, well.
You need that in order for it to break down. Now, if anybody out there happens to have some hydrogen peroxide in a big white 1-gallon jug.
How about that?
Mr. John?
Can we take somebody from the audience? Does anyone in the audience have any hydrogen peroxide?
Yeah, we got so excited.
Thank you so much.
We got so excited about this that we didn't add our hydrogen peroxide. Now, another thing that would be helpful would be if we had a beaker to pour it from. But let's just do an experiment here.
You're just going to dump it in?
I'm going to add a little bit. We're going to add a little bit here.
This is like real cooking in the kitchen with a scientist here. You don't need to measure. You just, add to taste.
We add to taste. Okay, so it's not too rapid. We'll add some in here.
It's going to hit.
It's going to come out, and we get. Now wait for it. Well, you're going to get some of that oxygen gas coming out. And it's going to get bigger and bigger and bigger. Now this is room temperature hydrogen peroxide.
It's pretty too.
Actually, now feel this. It's actually a little cool. I took it out of the fridge.
Oh yeah.
It is very pretty. So we're getting that really nice release of oxygen.
These look like sorry game pieces.
They do. Okay, come on down here. Okay, we have our hydrogen peroxide.
Hey.
There you go. That
something went wrong here. Now it's Papa Smurf's hat.
Now that is very cool. Yeah. But let's change another variable. All right. So this time, 4 molar. 4 molar. But this time we're going to look at the properties of the reaction when we have really hot peroxide and very cold peroxide. Okay, so that was nearly boiling water. This is ice water. What I'm going to do is add the peroxide to our flasks here.
Good idea.
Yeah, that's always, it happens. That's okay.
We learn. That's why you experiment.
That's why you experiment, yeah. And this is the warm hydrogen peroxide.
Okay.
Now, generally, chemical reactions happen faster when you have a warm chemical to start with. There's more energy there. Heat is a measure of energy. So I'm going to get this out of the way. Don't do anything quite yet.
Oh, trust me.
Okay, go ahead and add the soap. We can safely add the soap. We kind of color-coded this, red for hot, blue for cold.
I see.
Swirl it up a little bit. Swirl this. All right, so here's the big show. We're going to want to maybe step back a little bit when we do this.
You know what? Before we do this, let's remind everybody, if you have a kid who lives in Lucas County, you can bring that kid down here because today is Saturday, and the kid gets in free with a paid adult admission on Saturdays only.
Exactly. All right. Hydrogen peroxide, potassium iodide, soap, hot, cold. Here we go. 3, 2, 1. Pour it in. Step back.
You're right. You're right. It does happen faster.
I think I got the color. Yeah, oh yeah, I got the color right. The red one is the fast one. Yeah, exactly.
Thanks, Carl.
That's why we have personal protective equipment on, like your nice suit. Yeah, that was quite dramatic, right?
Sure.
Hot and more concentrated.
If we do this again, you get the hot one.
Okay.
All right.
All right.
We can sit here and watch
this. It's just going to keep going. It's very satisfying to see the colors.
That's fun when you do this in the Extreme Science Theater and the kids come up and they watch it boil over and over because it does go on for some time.
They do. And you know, it gives off heat too. You can actually see it's an exothermic reaction, giving off heat with that steam coming off the top. And yeah, it's just going to make a really big mess that you can help me clean up.
Oh boy. You know what? I gotta shake your hand. That's how you imagine it.